Okay, so welcome to Unit 6. This is going to be the unit on simple harmonic motion. This is a little bit short of a unit. There's two big topics really in this unit. There's the period of a simple harmonic oscillator and then the energy of a simple harmonic oscillator. And so over these next couple of videos, we're just going to really talk about some basic terms. What is simple harmonic motion? We're going to look at the mass spring system. We're going to look at pendulums, and then we're going to bring it all together at the end. We'll talk about energy. Okay, so this first video is really going to focus on just some terms, right? And we're going to review two relevant terms, but then we're also going to introduce in a third term called the restoring force. Okay, so the force of gravity. The first term that we're going to look at is the force of gravity. We, if you remember way back from Unit 2, we call this as weight, right? So the force of gravity that an object experiences is its weight. We can calculate that by the formula F sub g equals mg. So Fg is the symbol for weight or the force of gravity. It is measured in newtons. Again, abbreviation of N. Remember, all forces are abbreviated in, or is the unit is newtons. M is the gravitational mass, and all masses are measured in kilograms. So if you're given it in grams, you need to convert to kilograms because remember, physics uses the MKS metric system. G, sometimes we call this acceleration due to gravity, but the more technical thing is it's the gravitational field strength, and it has a unit of or a value of 9.81 newtons per kilogram, which is also that meters per second squared. All right, the other force, because we're going to look at mass spring systems, or the other term is the spring force. So remember, springs all obey something called Hooke's law. Hooke's law is just really a relationship relating the force and the elongation. And so the formula is FSP equals negative KX. Now we're really going to talk about what is this negative sign and how does that play into everything. And so FSP, that is our spring force. That's our variable for spring force. Again, it's a force, so it's going to be measured in newtons. K is the spring constant, or sometimes referred to as the force constant. This is going to be measured in newtons per meter. And so basically it just tells you how much force you have to apply to get it to stretch 1 meter. Slinkies, everyone loves a slinky, that's the way the song goes, right? Has a low K value because it's very easy to stretch it. And then garage door springs, right? They have a high K value because it's very hard to stretch it or even compress it. X is what we call elongation. Sometimes you'll see it written as deformation. And the way to think about this is like acceleration, where acceleration is the whole process of accelerating, so speeding up, slowing down. Elongation is the whole process of stretching or compressing. And the reason why people only want to pigeonhole it to be uh, stretching is because of that word long in there. But remember, it's going to actually account for both the stretching, which is pulling apart, or the compressing, which is pushing in together. And this is going to be measured in meters. So again, if you're in centimeters, because that's often what they'll do, springs don't stretch meters at a time. They stretch or compress centimeters at a time. So they're going to put that, they're going to use those units. So make sure you get it back into meters. All right, now kind of a new term and really what does this negative sign in Hooke's law or the spring force formula bring into play? So a restoring force, right, is a force that attempts to bring an object back to its equilibrium, all right, position. So everything wants to go back to resting. And so this restoring force does that. It brings it back, it accelerates it back into that equilibrium position. It is dependent on really the displacement. And you can see in the equation, F equals negative Kx. So it does matter on how far you stretch it, compress that spring. It will act though in the opposite direction of the displacement because it is going to want to restore. So if I have a spring on a table and it's bouncing back and forth, if my spring is moving in this direction. Well, to get this to slow down, my restoring force has to go in the opposite direction. Okay. So that's my restoring force, right? Where the blue arrow represents the motion or the velocity, right? How do we get velocities to slow down? We accelerate in the opposite direction. Okay. And so the last thing, the two examples of restoring forces that we have that we're going to really focus on. One is the spring force, right? So the spring force acting on an object attached to a spring, oscillating back and forth. And the other would be when we talk about pendulums, and that's going to be gravity. But it's only going to be a component because as a pendulum swings, right, only a piece of it is acting at its highest point, and it's going to be the horizontal component. That is what's going to be the restoring force or the restoring acceleration, if you want to say. All right, so in the next video, we're going to focus on really what is simple harmonic motion, what are some of the examples of simple harmonic motion.